Okay. Um, Good day, students. I will be looking at motion along an inclined plane. Okay, motion along an inclined plane. Okay. Now I want you to pay attention to this. Let's have an inclined plane like this. Please pay attention. Okay, and we have a body on an inclined plane. A body like this. Remember, the body we have a weight. All right, and the weight will be mg. Okay, the weight will act like this. Okay, now pay attention. The weight will act like this. Okay, and then we have a force pulling it right down like this, pulling the body down, that naturally wants the body to slope down when it is on an inclined plane. And let's call this force F. This force F is trying to pull the body up. This force is pulling the body down. This force here is natural. All right, when you put a body on an inclined plane, it naturally wants to slope down, except a force pulls it up, right? Do you understand what I'm saying? Okay, now then we have a reaction. We have a reaction. Now, did you observe now that the reaction is perpendicular to the surface? The reaction on a body is always perpendicular to the surface on which the body, are you with me, is lying. The reaction is not always perpendicular to the weight. It's not always in the direction of the weight. It's not always in the opposite direction of the weight. That's what I'm trying to say. It's always perpendicular, to the surface in which the body is lying. Is that clear? All right. Is that clear? All right. So let's look at this. Now, our aim is to, find all the values here, one way or the other. Okay. So if we have a reaction here, let's make an extension here. Let's make an extension here. If we make an extension here, we have a right angle triangle. All right. Now, supposing this is angle theta. All right, if this is angle theta, it has been proven that if this is angle theta, all right, this angle here is also angle theta. Okay, if this is angle theta, the angle here is also what? Angle theta. Okay, now the force acting here is the force acting here. The force acting here is equal to the force acting here. So this reaction. All right, so now if we can find this place, all right, we can know this place. If we can find this force, it is equal to this force. Remember, for every action there's an equal and opposite reaction. So the reaction here is equal to the reaction here. Is that clear? All right, so now let's lift this and let's bring it here. Let's lift it and let's bring it here. We have this is mg, this is theta. This is opposite hypotenuse. That's a sine. So this will be mg sine theta. This is adjacent hypotenuse. This will be mg cos theta. So that means this is mg cos theta. This is mg sine theta. Pay attention. This is mg sine theta. This is mg cos theta. So that means this reaction, are you with me, is the same thing as mg cos theta. Are you with me? So we say reaction equals to mg cos theta. Are you with me? While this force here is mg sine theta. Are you with me? All right. So with that, we are able to analyze the forces involved when on a body is on an inclined plane. It has a weight. This is the reaction. This is the force that wants to pull it down, and this is the force that is pulling it up. All right. This force is rather applied. Are you get what I'm trying to say? Is applied to keep it up. Are you get what I'm trying to say? All right. So if the body, all right, if this F, okay, equals to mg sine theta, all right, okay, the body is at rest. Okay, the body is at rest. That means this has balanced this. I get what I'm trying to say. This has balanced this. So, but if this force is greater than this force, then it will move up. If F is greater than mg sine theta, all right, the body, all right, will move up. We move up, all right, the body will move up the plane. Okay, so that means this F is greater than mg sine theta, so it will move up. So in that case, taking a cue from last class, we know we have net force equals to ma, right? Net force equals to ma. And what will be the net force? Let's assume that this body is moving up. It means that will be F minus mg sine theta equals to ma. So with what I've just derived now, we can solve some questions. Okay, we can solve some questions that we can be asked. Okay, that we can be asked. All right, so let's take an example. Look at this. I want you to pay attention to this. An object whose weight is 10 kg is placed on a smooth plane inclined at 30 degrees to the horizontal. Find the acceleration of the body as it moves down the plane. Did you observe that? Find the acceleration, all right, of the body as it moves down the plane. So that tells you that the body, no force is pulling the body up. So that tells you that it was placed there and then it's moving down. So because you need to be careful with the words that you have. So let's try to solve it. All right, an object. Okay, look at this. An object. We have this on an inclined plane. All right, it's 30 degrees. And we have the object like this. All right, the mass is 10 kg. All right, so the weight will be 10 times g is 10. That will be 10 times 10. That will be 100 newton. That's the weight. I get what I'm trying to say. And we can have something like this. Okay, that is equal to the reaction. This will be 100. This will be 30 degrees too. 100 cos 30 degrees. While this place will be 100 sine 30 degrees. And it is equal to this place, 100 sine 30 degrees. Now, this force here is 0. Because we were not informed that a force is pulling it up. We're just told that it is placed on an inclined plane. So that means that it is naturally moving down. I get what I'm trying to say. It is naturally moving down. All right. So the question now says, find the acceleration of the body as it moves down the plane. So if the body moves down the plane, which one is greater? Is it this 100 sine 30 or this F? It is this one. Because F itself is even 0. So that means that net force equals to MA. And what's our net force? This place minus this place. 100 sine 30. All right, minus F equals to MA. What's our F? 0. 100 sine 30 minus 0 equals to MA. What's our sine 30? Sine 30 is 0.5 minus 0 equals to, what's our M? Our M is mass, which is 10 times A. Okay, so we have 100 times 0.5, which is 50 minus 0. All right, that's gone, equals to 10A. So we have A equals to 50 over 10. A equals to 5 meter per seconds squared. Okay, A equals to 5 meter per second squared. Is that clear? So that's the acceleration. Now, then the next question says that the velocity attained after 3 seconds. The velocity attained after 3 seconds if it starts from rest. Now that's equations of motion. Okay, that's equations of motion. All right, if it starts from rest, means u is 0. Okay, it means u is equals to 0. And remember that our acceleration is 5 meters per second squared. We are looking for final velocity, and then the time is 3 seconds. Okay, all right, so which formula we work on? That will be v equals to u plus at. Okay, what's our v? That's what we are looking for, equals to u0 plus 5 times 3. That will be 0 plus 15. So that will be 15 meter per second, not second squared. Okay, all right. And then the second one says that the velocity, if it moves with an initial velocity of 5 meter per second. So u is 5 meter per second. Our acceleration is 5 meter per second squared. Okay, our final velocity, that's what we're looking for. Then our time is 3 seconds. So we are still using the same formula, v equals to u plus at, but this time around our u is 5 plus 3 times 5. That will be 5 plus 15. That will be 20 meter per second. Okay, all right, so we stop here for today. I'll send in classwork later on. God bless you.